Hi everyone, my name is Isiki. Today I will talk about Coulomb's law. So at the end of this lecture, you are able to understand what is Coulomb's law and how to apply the Coulomb's law to find the force between two charges. So now let's look at the Coulomb's law. This Coulomb's law is named after a scientist. His name is Charles Augustin de Coulomb. So he was a French military engineer and expert in mechanics and physics. So he initially worked on engineering project, but later on he turned to more scientific research. So his major contributions to physics came from his studies on electricity and also magnetism. So Coulombs conducted experiment to measure the force between the charger using a torsion balance. So this is a torsion balance. It is a very sensitive instrument, and it consists of a horizontal rod suspended by a thin wire, a small charge sphere. So when we take the sphere and rub it, okay, with another object, okay, so the object will be charged. So the sphere will be charged. So when we place the sphere back to this torsion balance, okay, we can find that two spheres start to repel each other, okay, because similar charge will repel each others, and the deflections, okay, can be measured from the scale which is on the body of the cylindrical glass case. All right. So based on the experiments, so Charles has come up with the law that is the Coulomb's law, and he used the Coulomb's law to deal with the force, okay, the force of a point charge acting on another point charge. It means that if you have two charges, one is positive charge and one is negative charge, okay, you can find the force of the point charge acting on the other point charge. And later on, we can use this Coulomb's law to find the electric field intensity and also the electric flux density. So there are basically three very important points that he find out from his experiments. So the first one is two like charges repel one another, whereas two charges of opposite polarity attract each other. So this means that if you have two charges that is with different polarity, the force will make them attract each other. Whereas if you have two charges with different polarities, so the force will make them repel one and another. Okay, so this is the concept, okay, of the Coulomb's law. And the second point is the force acts on along the line joining the charge. So if you wish to find the force, right? So let's say here you have a positive charge and here you have a negative charge. So the force will be acting along the line that joining the charge, okay? So this is the force, okay? This is the force of a positive charge acting on a negative charge. And the third one, the strength, okay, the how strong it is proportional, proportional to the product of the magnitude. So the force here is proportional to the product, okay, product of the magnitude of the charges. Means that if you have two charges, so here you will have Q1 and Q2 proportionals, and inverse proportional to the square of the distance between them, okay, square of the distance, okay, so this is the distance, okay, square of the distance between two forces, okay, so this is the distance, okay, so this is the Coulomb's laws. Okay, before we go deeply into these equations, I want you to look at some facts about the charges. Okay, so for the electric charge, the unit, okay, unit is C. C stands for the coulombs, and 1 coulomb is approximately equal to 6 times 10 power adding electrons. Okay, imagine how many electrons in 1 coulomb. And the polarity of the charges may be positive and maybe negative. This one we already know. It depends on how we rub okay, the material, and where is their position in the triple electric series. And like charge, okay, repel, okay, and opposite charge, they attract each others. Okay, so here this is the Coulomb's law. So as you can see from this figure, so for the Coulomb's law is used to find the force, okay, acting between two charges. So you have a Q1, okay, the first charge, and you have Q2, and both of them, they are separated by a distance, okay, R. Okay, so just now I have explained to you, okay, the force between two charges is proportional to the product of two charge and inverse proportional to the distance. Okay, so you can see this parameter in the equations. So here you have the Q1 and Q2 here, Q1 and Q2, and here you have the R squared, and here you have this 4 pi epsilon, and you have this one, unit vector R. Okay, so for your information, the force is a vector quantity. Okay, when it is a vector quantity, you will have the directions. So this parameter basically representing the directions of your force. Okay, the direction of your force, and this 4 pi epsilon naught, okay, is actually equal to, is come from here. Okay, 4 pi epsilon naught is actually the Coulomb's constant. Okay, we said that this is the Coulomb's constant. Coulomb's constants. Okay, so we can take this K and replace it here. So the equations will become F equals to Q1, Q2, okay, over if you multiply the K here, okay, multiply the K, R squared, and then unit vector R. Okay, unit vector R. So this one is the equations exactly like this one. Okay, so this is the equations to calculate the force. And one thing, if you observe here, is you can see this subscript, right? Okay, you can see the subscript. Here you have 1, 2, 1, 2, 1, 2. Okay, they are matching each other. So what is the meaning of 1, 2? Okay, 1, 2 representing that, okay, if you want to find the F12, it represents that you want to find the force acting on the Q, okay, acting on the Q due to 1, okay, this one, the blue one. So this Q1 will exert force to the Q2, okay. So we are calculating the F12. If it is the other way around, it will be F21. Okay, later we will explain about this F21. So I'm sure that there are some symbols that you are quite familiar with, especially this one, unit vector R. If you remember, this unit vector R we learned before in the multivariable calculus. It is equals to vector R divided with the magnitude of the vector R. Okay, so this is related to the distance. Okay, so this thing you must be very clear when you want to calculate this R12. Okay, if it is R12, okay, you are going to take the positions, okay, of the let me give you an example. If the coordinate of the Q2 is x2, y2, and z2, and the coordinate of the Q1 is x1, y1, and z1, and you are going to find this R12. So the formulas, okay, would be that this one, okay, x squared, y squared, z squared, okay, the minus x1, y1, and z1. Okay, so it is very important. You must be able to state this correctly. Read the question what they want. Okay, if they want to find the force acting on Q2 because of Q1, you are going to use this symbol. Okay, and this thing cannot be wrong. Okay, if this thing is wrong, your direction will be wrong. Your magnitude will be okay, but your direction will be wrong. So the force directions, okay, will be wrong.